Now let's talk about the relationship between the two events. Two events A and B are said to be independent events if the occurrence of one event will not affect the occurrence of another event. So for example, if you roll two dice, so the getting an even number in one die will not be dependent on getting an odd number on another die. So those two events are independent. And if the two events are independent, then probability of A intersection B is equal to probability of A times probability of B. So that means whether the conditional probability, so probability of A given B will be equal to probability of A, because whether B has already happened or you already know the B event, what is the result, it will not affect the happening of event A. So therefore probability of A given B is equal to probability of A, or probability of B given A is equal to probability of B. Or we can also say mathematically as, because probability of A intersection B is equal to probability of A times probability of B, and we know the conditional probability formula, that is A over B is equal to probability of A intersection B over probability of B. So which is equal to probability of A times probability of B, because A and B are independent events, and substituting that in this formula, and this will get cancelled, and therefore you will have probability of A. That is, whether the event B has already happened, the probability of A given B is equal to probability of A. Right now, second relationship is if the two events are mutually exclusive. Two events are said to be mutually exclusive if the two events are disjoint. So if we roll a die, then if A is a probability of getting a even number and B is a probability of getting an odd number, then A and B are mutually exclusive events. Or if a coin is tossed, then getting a head and getting a tail are mutually exclusive events. Either you can get head or you can get tail. You cannot get both. So therefore, it is your mutually exclusive events. Mutually exclusive events are disjoint events, that is no elements in common. Now, two basic rules of probability. The first one is multiplication rule. Multiplication rule, we know that probability of A intersection B is equal to probability of A times probability of B if the two events A and B are independent. And if it is not independent, then we can write the probability of A intersection B as probability of A over B, or A given B times PB. So it is from the conditional probability. The second rule is addition rule. So if the A and B are the two events, the probability of the union of A and B is probability of A plus probability of B minus probability of A intersection B. Now, if the two events are mutually exclusive, that means it is disjoint event, and then it is probability of A intersection B is equal to 0, and hence probability of A union B is equal to probability of A plus probability of B. So let's see an example. So a hamburger chain found that 65% of all customers order French fries, 78% order soft drinks, and 55% order both. What is the probability that a customer will order at least one of these? So you can pause the video and think a little bit that how we can solve this one using the probability rules. So if we think the event A as the customer ordered French fries, then probability of A will be 0.65, that is 65%. B is ordering soft drinks. So probability of B is 78%. So we got probability of A and probability of B. And ordering both means probability of A intersection B, because both they are ordering, that is 55%. So we know that probability of A, probability of B, and probability of A intersection B. So you have to find what is the probability that a customer will order at least one of these. At least one of these means either one or this one or both. So that means A union B you have to calculate, and using the previous formula, you can calculate A union B as probability of A plus probability of B minus probability of A intersection B. So you can see French fries 0.65, soft drinks 0.78, and French fries and soft drinks it is 0.55. So French fries or soft drinks will be given as this one, and that is 88% is your probability of French fries or soft drinks. Right, second example, a box contains 2 white balls, 4 yellow balls, and 5 red balls. A ball is selected from the box. What is the probability that the selected ball is red or yellow? So, probability of selecting a red ball is number of red balls divided by total number of balls. And probability of selecting a yellow balls is yellow balls divided by total number of balls. So we can see here probability of red balls. Red balls are 5 in number, so probability of red is 5 divided by total number of balls, that is white plus yellow plus red is 11 balls, so 5 over 11. Probability of yellow balls is yellow, that is 4 divided by 11. And probability of red and yellow. So the ball can be either red or it can be yellow. It cannot be both. So therefore probability of R intersection Y will be 0, because this is your mutually exclusive events. These two are mutually exclusive events, and therefore you can calculate the probability of R union Y, which is using the addition rule, you can find 9 over 11. Right now, this is an exercise based on the probability. You need to calculate. So calculate PA union B if PA is equal to 0.6, PB is equal to 0.7, and PA intersection B is equal to 0.5. So I can give you the hint how to do it, and you can do your own. So here you can write this as probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. Right, so it is equal to 0.6 plus 0.7 minus 0.5, and you can calculate what it is will be. Second one, calculate PA intersection B if PA union B is 0.8, PA is 0.4, and PB is 0.6. So using the same formula here. So this is your probability of using the same formula, just the other way around, that is A intersection B is equal to probability of A plus probability of B minus probability of A union B. Right, just the same formula, addition rule, writing in different ways. Just substitute the values, addition and subtraction, and calculate the value. Third one is also based on the same formula. So PA union B is equal to probability of A plus probability of B minus probability of A intersection B. And then you can calculate, this is 0.7 given, Probability of A is not given. Probability of B is 0.4 and probability of A intersection B is 0.3. You can simplify and calculate what is your probability of A. Right. And the last one, calculate probability of A intersection B. When probability of A is equal to 0.6 and the two events are complementary, what is the probability of B? So the two events are complementary means it is mutually exclusive and mutually exhaustive events. And for mutually exclusive and mutually exhaustive events, your PA intersection B is equal to 0 and PA union B is equal to 1. Right, so you can write here as your PA union B is equal to PA plus again the same formula PB minus PA intersection B. Right now A intersection B is equal to 0, so this is 0, and PB we have to calculate. PA is given as 0.6, and because it is also complementary, so both mutually exhaustive and mutually exhaustive and mutually exclusive, so therefore probability of A union B is equal to 1, and therefore probability of B, you can write probability of B is equal to 1 minus 0.6, which is equal to 0.4. Right, so this completes the total probability section. We can discuss in the next session whatever doubts you have.